let's do a quick review of regression, how this works. So here's the idea, is that I have a set of data. I have the return for some stock I, and I have the return for the market. And in the first month, I have the return of the stock and the return of the market. And in the second month, I have the return of the stock and the return of the market. And same for the third month. And let's assume that I have 60 months worth of data. I have 60 pairs of data. In each month, I have the return of the stock I and the return of the market. And what I'm going to do is I'm going to graph these. And I'm going to have the return of the market on my x-axis, and I'm going to have the return of the stock on my y-axis. And in the very first month, I'm going to look at my paired data, and I'm going to see that, okay, the market was up and the stock was up, and so I put a dot right here. And in the second month, I see that the market was down and the stock was down, and I put a dot right there. And in the third month, I can see that the market was up, but the stock was down, and I end up with a dot right there. And I'm going to end up with 60 dots. And now what I want to do is figure out a relationship between the return of the stock and the return of the market. So I'm going to write down this equation that the return of the stock is equal to the alpha plus the beta times the return of the market. And now I have a linear equation where I have this alpha term, which is going to be the intercept, the amount that I move up the axis, and beta is going to be a slope of a line. And so given that I have all these 60 dots here, I'm going to draw this line based on the value of beta. And I'll do a bigger dot there. And now notice that I haven't actually gotten to all the dots. For example, to get to this dot right here, I need to go up alpha. I need to go the return of the market times the beta. That just brings me to there. But to get to that, I actually have this little extra spot. And to get to this dot, I have to go down, and to this dot, I have to go up, and then to this dot, I have to go down. And so to actually describe the return of the stock, I have the alpha, which gets me to the intercept, plus the beta, which tells me the relationship between the return of the market and the stock. But I still need, to get to this last spot, I still need a little bit extra, and that's going to be the error term. And so to get to the 60 different spots, I'm actually going to need 60 different error terms. And so the next thing I'm going to do is I'm going to take each of these error terms and I'm going to add them up. Oh, I can't add them up actually, because if I add them up, then the positive numbers and the negative numbers are going to cancel each other out. So what I need to do is square them, and then I'll take the sum of my squared errors. And now I can have a rough idea of how good the fit of this line is. And the next thing I do is I choose an entirely different alpha and an entirely different beta. This gives me a whole new line. This gives me another 60 error terms. And then I can scrap my old errors. I can have a new stack of errors, and I can have a new sum of squared errors. This is a sigma. Oops, undo that. A whole new set of errors. This is a summation sign, and this is an error. I'll have a whole new sum of squared errors. If it's the case that my new sum of squared errors, based on my new alpha and my new beta, is smaller than my old sum of squared errors, then my new line is a better fit than my old line, and I'm good to go. And I keep doing this until I choose the alpha and the beta that give me my least sum of squared errors. And that's going to be the line that is the best fit. And of course, we do this in Excel. So let's go do an example in Excel.